We need to differentiate each of these functions, giving our answer in their simplest form. Now, both of these examples are examples of using the quotient rule because we've got one function divided by another function. One function divided by another function. I've just put a reminder of the quotient rule up here where you can see one function divided by another function, and this is the rule we use to differentiate it. So in this first example, my u is going to be the x squared and my v is going to be the x plus 4. So differentiating the x squared, I get 2x. Differentiating the x plus 4, I get 1. Right, now to apply the quotient rule to this. Okay, so this quotient rule here. So u dash v minus v dash u over v squared. So u dash times v minus v dash, which is 1, times u over v squared. Just simplifying that then, we've got the 2x squared plus 8x minus x squared. I'm not going to expand the brackets on the bottom because that's not going to help me to make it simpler. Expanding the brackets on the top helps me to make it simpler because I can collect up these like terms. To be x squared plus 8x over x plus 4 all squared, and then we can factorise an x outside here. And that is my answer in its simplest form. Right, next example. The 2e to the power x plus 1, that's going to be my u function. And the 1 minus 3e to the power x, that's going to be my v function. Right, so differentiating the 2e to the power x plus 1. Well, the 2e to the power x differentiates to be 2e to the power x. And the 1 will differentiate to be 0. The v, well, the 1 is going to differentiate to be 0, and the minus 3e to the power x will differentiate to be minus 3e to the power x. Now applying the quotient rule. So u dash times v minus v dash times u all over v squared. We can see the two minuses here will make a positive. And now I just want to simplify this if I can. I think there's a few things on the numerator that will simplify quite nicely. I'm going to leave the denominator as it is though. So expanding the numerator out then, I've got the 2e to the power x times 1, which is just 2e to the power x. I've then got the 2e to the power x times the minus 3e to the power x. So that's going to give minus 6e to the power 2x. The 2 times the minus 3 gives the minus 6, and the e to the power x times e to the power x. To add the powers, and you get e to the power 2x. Moving on to the second set of brackets, the 3e to the power x times 2e to the power x is going to give 6 because of the 2 times the 3, and e to the power 2x because of the e to the power x times e to the power x. And then we've also got the e to the power x times the 3e to the power x times the 1. And the nice thing is now then we can see these two things are going to cancel out, and we can add the 2e to the power x and the 3e to the power x to give 5e to the power x. And that's my answer in its simplest form.